Dear students, under the topic definite integrals, here we have problem 8. Prove that integral 0 to pi theta sine cube theta d theta is equal to 2 pi by 4. So in order to prove this, let us take the integral on the left hand side to be equal to capital I. So capital I will be equal to, let us mark this as equation 1. So since we have taken the left hand side as capital I, we have to prove that the value of I is equal to 2 pi by 3. Now here we are going to make use of property phi. So what does property phi say? So now we are going to apply this property in equation 1. So how shall we apply? Now at the place of a, what do we have? A is equal to pi. So the upper limit is a equal to pi. So therefore the given integral capital I can also be written as integral 0 to pi f of a minus x, that is f of pi minus x. Now f of pi minus x is the function, this is f of theta. Now here we have to write pi minus theta because the variable here is theta. So therefore we will be having at the place of theta we have to replace by a minus theta. What is a? A is pi. So at the place of theta we have to replace by pi minus theta sine cube, here also pi minus theta, then d theta. Now further we know that sine 180 minus theta, 180 is represented as pi, so sine pi minus theta is equal to what? Sine theta, because it lie in the second quadrant and sine is positive in the second quadrant, and so we get sine pi minus theta to be equal to sine theta. So this has to be rewritten as, so capital I will be equal to integral 0 to pi. So this pi minus theta will be the same. So instead of sine cube pi minus theta, we will have sine cube theta, because sine cube can be written as in this way, that is sine pi minus theta the whole cube. But what is sine pi minus theta? It is sine theta. So we will get sine cube theta. That is what we have got here. So instead of this, we will get sine cube theta d theta. What is this actually? It is capital I. So capital I is also equal to 0 to pi, pi minus theta, sine cube theta d theta. We shall mark this as equation 2. Next what we will do? We will be adding equation 1 and equation 2. So adding the left hand side of equation 1 and equation 2, here we have I, and on the left here we have I again. So it is 2I. On the left it will be 2I is equal to, on the right, what is the right hand side of equation 1? This. So that integral we have to write. So let me write that. Integral 0 to pi theta sine cube theta d theta, plus the right hand side of equation 2. So what is the right hand side? This integral we can split up and write with pi multiplied with sine cube theta as one integral, and the theta multiplied with sine cube theta as another integral, that is plus integral 0 to pi. The first integral will be pi multiplied with sine cube theta. So pi sine cube theta d theta, and then we have this minus, so minus integral 0 to pi. Next is what? Theta multiplied with sine cube theta, so theta multiplied with sine cube theta d theta. Now if you see, this first integral is a positive integral and this integral is same with a negative, so this integral and this integral will get cancelled, and so we get 2I to be equal to integral 0 to pi, and then we have pi sine cube theta d theta. So now let us evaluate this integral, for which we are going to write this sine cube theta as sine squared theta multiplied with sine theta. So this sine cube theta will be changed and written like sine squared theta multiplied with sine theta in order to make a substitution. So why we are doing like this, you will understand as we follow the next steps. So kindly follow carefully. So I have taken and I have written that integral over here. So this integral will be equal to integral 0 to pi pi multiplied with, instead of sine cube theta, we can just split and write it as sine squared theta multiplied with sine theta d theta. So why I have done like this? Because I need cos in this integral in order to make substitution, so that we can solve this integral by substitution method. So how can I bring in that cos? We know that sine squared theta is equal to 1 minus cos squared theta. It is because we know that sine squared theta plus cos squared theta is equals 1. So from this we know that sine squared theta is equals 1 minus cos squared theta by the trigonometric identity. So when we use this identity over here, what we get, this integral will be equal to, so 2i is equal to 0 to pi multiplied with, so instead of sine squared theta, we will have 1 minus cos squared theta multiplied with sine theta d theta. Now I am going to use the method of substitution. So what substitution I am going to make is, so in this integral I am going to put t is equal to cos theta. If t is cos theta, what will be dt? That is dt by d theta. So dt will be equal to, what is the differentiation of cos theta? It is minus sine theta, and the d theta we can write here. So dt is equal to minus sine theta d theta. Whenever we make a substitution, we should also check with the limits, how the limits changes after the substitution. So what are the limits? The lower limit is 0. So now the limit is for theta. So when theta is equal to 0, what do we get? Cos theta. So when theta is 0, t will be equal to cos 0. What is cos 0? Cos 0 is equal to 1. So we get, when theta is equal to 0, we get t to be equal to 1. So this is the lower limit. What about the upper limit? The upper limit is pi. So when theta is equal to pi, what about t? So t will be equal to cos pi. But what is cos pi? It is equal to minus 1. So therefore when theta is equal to pi, t is equal to minus 1. So these are the change in the limits. Now we shall substitute all this in this integral. So therefore this integral changes as 2i is equal to integral, what is the lower limit now? The lower limit is t equal to 1. So 1, the upper limit is minus 1. So 1 to minus 1, and pi comes as it is. And here 1 minus, what is cos squared theta? We know that cos theta is t. So cos squared theta will be t square multiplied with sine theta d theta. But what is sine theta d theta? So if you see here, it is dt, and this negative sign we have to take this side. So we will be having minus dt. So this is the substitution that we have made. So from this, we will take this negative sign outside the integral. This pi is a constant, so pi also we can take outside. So integral 1 to minus 1, 1 minus t square dt. Now we shall integrate this. So that will be equal to, so 2i is equal to minus pi. Now after integration, so if you integrate 1 with respect to dt, it will become t. Then minus integration of t square with respect to dt is t cube by 3. And after integration, the limits are from 1 to minus 1, that we have to write. Then that is equal to minus pi, and within the bracket, first we will substitute the upper limit. Throughout fully we will substitute the upper limit. Upper limit is minus 1. So at the place of t we have to put minus 1, and then minus, again we will have minus 1 cube, but minus 1 cube is minus 1 only. So minus 1 we have, and that gets multiplied with this minus, and so it becomes plus 1 by 3. So upper limit is over. Minus the lower limit. Minus lower limit is, first if you substitute 1 here, you will have 1. And because it is minus, this minus into minus will become plus. So plus, again 1 when you substitute here, 1 cube is 1 only, so 1 by 3. So we get this. Now if you see, this will be equal to minus pi multiplied with minus 1 will give us minus 2. And 1 by 3 plus 1 by 3 will give us 2 by 3. So plus 2 by 3. But what is 2 by 3 minus 2? So this is minus pi. We will write it in this way, 2 by 3 minus 2. So that is equal to minus pi. The LCM is 3 and this comes as it is. So 3 multiplied with 2. So 3 2 times is 6. So that's equal to minus pi multiplied with 2 minus 6 is minus 4 by 3. So minus into minus will become plus. So we will have 4 pi by 3. So therefore we are getting, what is the left hand side? 2i. So 2i to be equal to 4 pi by 3. And so from this, what will be I? Bring this 2 to the right, it goes to the denominator. So I will be equal to 4 pi divided by 3 2 times is 6. Now this can be cancelled, 2 2 times and 2 3 times. So that's equal to 2 pi by 3. Therefore I is equal to 2 pi by 3. What is I actually? It is the given integral that has to be evaluated, that has to be proved. So I is equal to 2 pi by 3, which has been proved that the given integral is equal to 2 pi by 3. So hence we have proved the required result. So therefore integral 0 to pi theta sine cube theta d theta, which was taken as I, is equal to 2 pi by 3. So hence we are done with the proof. So hence proved. Hope you have understood how to prove this problem. And for more problems under this topic, kindly follow the upcoming video lectures. Thank you.